Welcome to our presentation on using the React Native ecosystem with UI Engine 1. When you begin a project with the CLI using the UI-tv init command, the results are pretty bare bones. This is by intention. We don't want to opt you into too many choices that would require effort to undo. But there is a wide world of free and open source packages that we can take advantage of in the NPM registry. In this video, we'll look at a number of them that can enhance your experience using React Native. This video also exists as accompaniment to the release of UI Engine 1 6.0. Following in the weeks after, we will be making TypeScript types available for all of the engine's APIs. Bear in mind that the versions of packages and setup processes are liable to change over time. Also as a reminder, React Native on UI Engine is compatible with many NPM packages, but has the following restrictions. It cannot contain any native code. The UI engine binds with C++ rather than with annotations in iOS or Android, for instance. It cannot contain any Node.js code since we're not running in a Node environment, and similarly, it cannot contain any browser code since we're not running in a browser. With that out of the way, let's get started. First, we'll examine Babel, a package for transforming code for the purposes of polyfilling and introducing custom syntax. As it turns out, all React Native on UI Engine projects already include it to transform JSX into plain JavaScript. There's not much we need to do to modify as everything is already bundled into presets and plugins. One thing to make sure is that these are in dev dependencies and not dependencies, as they may be at project creation. Because Babel runs at build time, we don't need its packages in our final bundle. We can also make sure that we're getting the latest preset version. And with that, we're done. But do note that configuration is split between the file relative .babelrc and the project-wide babel.config.json. While it may be tempting to make everything project-wide, be aware that this affects including dependencies as well, which isn't appropriate in all cases. Some dependencies will need to set up their own Babel configuration, and global settings may interfere with that. Next, we move on to TypeScript. Adoption of TypeScript is something you'll want to consider for your project. While it does add syntactic overhead, it is incredibly widespread in 2020 and considered by many to be a best practice. Catching errors statically with the type system could save hours of debugging runtime issues. First, we'll need to add the package to our dev dependencies, including the types provided by the definitely typed repository for our major packages. Next, we'll add the types for the UI Engine APIs. As of this recording, they will be released shortly after 6.0. I'm currently using the slightly older 5.17 version, which is almost entirely compatible. Unlike other projects, this version reflects the engine version rather than semantic versioning. Additionally, you'll notice this line is a little longer than normal. Because the package is private, it doesn't belong to the definitely typed repository, which owns the @types namespace. TypeScript is configured by default to look in that namespace's folder for types. So we'll take advantage of that by making an alias with npm : that points to that package. Alternatively, you could also set the path manually in your configuration in the next step. Admittedly, that's a lot of @signs in the yarn command. 2 for the namespaces, 1 for the alias, and 1 for the separator. Wow. TypeScript is configured using a tsconfig JSON file. It's largely boilerplate since most configurations for UI Engine projects will be the same. Note that we're specifying JSX to follow React Native syntax. Additionally, we do not need to emit any JavaScript. This is being handled by Babel. We can now add convenience commands to our yarn scripts in package.json. This way we don't need to remember the exact invocation arguments to type check our project. And now we can take the bold leap of moving the index file to a tsx suffix, which is the TypeScript equivalent of JSX. We'll need to update the entry point in package.json. Lastly, if you so prefer, you can convert the class-based YI React app component to a function. If you're planning on using hooks throughout your project, this is a good first start. Next, let's look at ESLint. Many languages have what's known as a linter to catch common mistakes that, while not compile mistakes, are still considered a bad practice. At one point, there was a separate project, ESLint, for TypeScript, but it has been deprecated in favor of merging everything under ESLint. As before, We'll add the ESLint package and associated packages for TypeScript, React, and React Native to our project. Like with TypeScript, ESLint is configured using a .ESLint JSON file. Again, the boilerplate will remain largely the same, but unlike with TypeScript, you may have more reason to edit this file. ESLint is composed of rules, and in the extends block, we're setting a bunch of them in groups. Notice each item has either recommended or all. The all option is more strict, but you may want to consider it. While not shown here, you can also declare any project-wide rule settings based on your own preference, such as forcing arrow functions for components versus the function keyword. For convenience, we will also add a lint command to our repertoire of yarn scripts, and if we were to run that with the standard project created by the CLI, you would find that it flags our use of hard-coded color values. The best practice advice is that these should be variables, as a single color in isolation is an unlikely use case. We can comply by moving these to a separate colors.ts file. It also complains about alphabetic ordering, which we can quickly fix. Along with the linter, it is best practice to enforce a uniform style automatically with a tool such as Prettier. If everyone on the team is on board, it should put an end to debate during code review over anything style related. Configuration here, as well as with ESLint, will carry nicely into Visual Studio Code, which many developers use when writing TypeScript. You may notice a pattern here. First step is to add to the project. Second is to configure with a config file. In this case, you will want to substitute these and other values with however you prefer to style your JavaScript or TypeScript. Now you can have the debate once and lock it in for all time. We'll also quickly add an ignore file, which uses the same syntax as a gitignore file. This way we restrict Prettier to the JavaScript side of the project, leaving the build and C++ files alone. Node modules is ignored by default. And, surprise, we can also add a yarn script. Note that we're using the write argument, which will overwrite files it encounters. Since there's likely some deviation in the project from the rules as laid out, now is a good time to run the formatter and commit the results. The previous two steps were nice, but how can we make sure that our codebase stays clean in the long term? While we did add convenience scripts to make it easy to run these tools, inevitably, people will forget. To err is human. Thankfully, we can employ the ever-watchful eyes of an indifferent machine. Enter Lint-staged. It's a JavaScript wrapper around Git hooks that run our scripts at commit time, ensuring all new code is compliant. Unlike other dependencies, this one is installed using a project called MRM, which handles configurations in a reusable way. It will notice that we're using ESLint and Prettier and add them automatically. Underneath Lint-staged is a project called Husky, which integrates with Git hooks. While it did a decent job, MRM didn't quite nail the file filter. We'll generalize it to look at everything, rather than just JS, CSS, and MD files in the case of Prettier. Now we can verify that it's all working as intended by trying a simple violation, such as removing a trailing comma, and seeing if it will deny the commit. All going according to plan, you should see something like the following. In my case, the entire commit consisted of a style violation, so it rolled it back. If it was mixed in with regular commit lines, however, it would simply apply the correction and carry out the commit. Let's move on to talk about our first app-side dependency, React Query. This is a popular networking library that adds caching, stale data protection, parallelism, pagination, and more. If you're looking for an upgrade over the standard fetch function, consider this library. As always, the first step is installing the dependency using yarn. Note that this is our first non-dev dependency. Because we're using TypeScript, we need to give a type to the response that we expect from our API. In this example, we'll use the movie database, or TMDB's excellent free movie metadata API. Specifically, we'll be using the popular movies API, which returns an array of condensed items from which we want the ID, which we'll use later to get details, as well as the poster path URL fragment to show the poster as an image in a list. We'll also add a quick type for the error that we might get out of a query. Now we can execute our query. The URI is defined as a constant, and you'll note we need to get an API key by registering a free account with TMDB if you'd like to do this exercise locally. The useQuery hook provides many return values, but specifically, we will look at the is, loading, error, and data members. We type the useQuery hook with our expected response and error types. Its first argument is a unique key that identifies this query, which will be using the string popular movies. The second argument is the callback function, with which we'll use an inline async function that does the actual fetch and conversion to JSON from the response. Once complete, our response will be in the data destructured member we defined just before. With the isLoading and error destructured values returning from the hook, we can preempt the render by checking their state and returning early. Lastly, we can render the flat list with our list of posters from the result. The poster has been turned into a subcomponent, as we'll be adding to it in the next section. The data prop for the list pulls directly from the data member coming from the hook. And with that, we have our list of posters coming from a REST API using React Query. Let's finish things off by looking at React Navigation, the leading community package for navigating between screens in React Native. For one final time, we'll add our dependencies. We'll be using a stack navigator in this example. So in addition to the base package, we'll pull in the stack package. With React Navigation, routes are defined with a string key name as well as params, which are very similar to props. We'll start by typing those out now. The home screen will display the popular movies we made in the last example, so there's no need for additional information. By contrast, the detail screen will represent the movie details of a particular movie, so the route will need to know which ID we're referencing. Building from the previous example, we'll move the contents of You.i React app into a component called home screen. It will use the stack screen props type, which will give us the needed props such as the navigation object. That type's arguments will be the param list we defined in the last step, plus the string of the key that this screen represents. As an additional step, we'll add an onPress callback to the poster, which will call the navigation.navigate method. This takes the string key of where we're going, in this case the detail screen, as well as the param list, which in this case is just the ID of the movie. For the detail screen, we'll share many similar patterns with the home screen. We'll define the props in the same way, as well as the expected data from our details API call. For the props destructuring, this time we're only interested in the route object, which gives us the param list, in turn giving us our ID for this particular screen. On the useQuery hook for this page, the first argument, rather than being a fixed string like last time, is an array with two elements, a fixed string of movie details and the ID. These are serialized together to ensure that React Query's cache sees each distinct movie details page as separate. The rest of the page is nothing we haven't seen before. React Navigation works primarily off of two parts, a navigator and a router. Stack navigation is provided out of the box with a stack navigator and stack router, but unfortunately the stack navigator uses native modules to get a native look and feel on iOS and Android. We'll need to create a custom navigator that works more generically on the UI engine. To start, we don't need any additional options, so our custom stack navigator will have default navigator options. Next, we employ the Use Navigation Builder hook, which does the heavy lifting of binding it with the stack router. Note we're still using the default stack router provided by the library. For the render, we first wrap with a context that provides navigation to descendants. Then we render the current route by digging out into the current state. This will call the render function of either the home or detail screen. Next, we can add any navigation chrome we want around the screen. In this case, we'll check if the navigation stack is 2 or more screens deep, meaning back navigation is possible. If so, we'll render a back button that calls navigation.goBack to pop one screen back. Lastly, we'll use the createNavigatorFactory method provided by the library to expose our navigator as a function called createStackNavigator, an idiom used by all navigators in the library. Now we can finally add our navigator and screens to our app's entry point. We'll use our new factory method to create a stack component. Then in our root render, we'll wrap everything in navigation container as prescribed by the library, followed by our navigator specifying its initial route, and lastly our two screens as the innermost children, giving them their string name and a reference to the component to render. With that, we have a fully functioning, if simple, stack navigation system using React Navigation. The JavaScript and React Native ecosystem is a powerful tool to accelerate your work and ensure you and your team are following best practices. With TypeScript, ESLint, and Prettier, We can add the rigor of static typing while looking for bad patterns and ensuring consistent style. Lint-staged is a watchdog that will run these tools on each commit to keep your project validated in the long term. With React Query, we can take our networking to the next level. And while we barely scratch the surface, React Navigation gives us a complete navigation package with full flexibility to define any navigation scheme. Hopefully you will consider these and other packages in your present or future projects. While dependencies have their own costs, which we haven't discussed here, many are worth the weight that they add. With intelligent selection and diligence when adding to your project, they can become the cornerstones that allow you to focus on delivering value to your customers. Thank you for your time and happy hacking.